Okay, so now that we know what an amino acid is, we need to know how you get to a protein from an amino acid. So, amino acids are going to bond together and make a chain. We call that chain a polypeptide. This polypeptide here is made of 12 amino acids. This is just an example. Polypeptides can be different lengths. They could have different combinations of amino acids. It all depends on what these R groups are, what polypeptide we get. Now, this alone is not a protein yet. There still need to be a few things that happen to make a protein. To make a protein out of a polypeptide, the polypeptide is going to have to fold up. So like this, folded back and forth, it's going to get a little more compact. After that, the polypeptide is going to fold up even smaller, like this little squiggle I've drawn here. And finally, multiple polypeptides are going to bond together, and that is going to be our protein. That is how we make a protein out of amino acids. So, specific proteins and protein things you need to know. Each protein has a very specific shape, and that shape is characterized by many folds and many bonds. We call it globular. It is a globular shape. I think that's a great word. It looks like a glob. I couldn't describe this shape if I wanted to, and that's kind of what proteins are like. So we say they're characterized by many folds and many bonds. They're globular. And it's very important that we know that that shape is really important to it, even though it doesn't look like anything to us. You see, if I look over to the right, if you expose a protein to heat or acid, the bonds are going to break, unraveling or denaturing the protein. So I went from this tight folded up structure to this loose falling apart structure. This breaks the protein. It can't do its job anymore. You need to know that. That is called denaturing, and it happens when you're exposed to heat or acid. So for instance, if you burn yourself, you've probably denatured some proteins. Your stomach will also denature proteins when you digest your food. That way you can do hydrolysis, break those proteins down into monomers, and then use those monomers to make your own proteins. So some polymers to know and their functions. This is the last thing. Enzymes are proteins that speed up chemical reactions. You have these in your stomach, for example. Transport proteins live in the cell membrane, and they help molecules cross the cell membrane. They help bring things in and out of the cell. And then finally, you have structural proteins. Those are going to be the ones that make up body structures like muscle, hair, your nails, all kinds of parts of your body. One thing you should also know is that right here, I did not say that proteins give you energy, because proteins are not a good source of energy. This is a misconception that is very common. We often think of energy and proteins together because we think of proteins in terms of fitness. We know that you are supposed to eat a lot of proteins to stay fit. That is because they build up your muscles, and that is very important. It is not because they have anything to do with energy, because they don't. So please, please, please know for your test, proteins don't give you a lot of energy. That is not a function that you should know, because it is not a function of theirs. These are the 3 functions you should know, and they are specifically tied to these kinds of protein polymers.